Hi, everybody. I'm Chris Williams from Y2K Engineering, and we're about to get started here in Breakout 3. I want to welcome you to our presentation, Schooled by a School Zone, the conversion of a 15-mile-an-hour school crosswalk to a traffic signal. And it's my honor to introduce Sabina Ellis, who will be giving this presentation. Sabina Ellis is a professional engineer in Arizona, and she is the city traffic engineer for Mesa, Arizona. She has been a public servant at the city since 2012. In her current role, she oversees the traffic studies and temporary traffic control groups and is responsible for the development and implementation of an efficient and safe street transportation system in the state's third largest city. Prior to her time at the city, Sabina worked in the private sector for 5 years. Ms. Ellis is an alumna of the University of Applied Sciences in Würzburg, Germany. I have known Sabina for 11 years, and I find her to be one of the smartest and hardest working engineers that I know. In her free time, Sabina enjoys traveling, working out and hiking, I think even sometimes surfing. If we weren't virtual, I would ask you to join me in welcoming Sabina Ellis.
Well, thank you very much for that great introduction, Chris. I can give that back to you. You've been my mentor for a long time, and I really appreciate it. And I was really glad to work on this project with you. So as Chris mentioned, I'm Sabina Ellis, and I'm going to tell you a little bit about the story of how we converted a 15-mile-an-hour school crosswalk in Mesa, Arizona to a traffic signal. As part of my presentation, I'm going to give you a brief project overview to let you know what we started out with and what we dealt with the existing conditions. We're going over some design parameters, and I will hand that section over to Chris because he was or is with Y2K Engineering, and his group did the design for the signing and striping and the traffic signal. And then I'm going to tell you a little bit about the experience we had during construction and the issues we ran into while construction was going on. And then the big thing was really on the first day of school when we troubleshooted some things that didn't work out the way we had hoped they would. And ultimately, I have a cool drone video from the final project as it operates today. On the left here, you see a picture of when the 15-mile-an-hour school crosswalk was first implemented. That was around 1998 when the school was built. And with the 15-mile-an-hour school crosswalk, they also got a flashing setup for a dual speed limit zone. So we had school zone flashers that were flashing during the day when school was in session. And the speed limit was reduced from the standard 45 to 35 miles an hour during school hours. The picture also shows the school driveway in the middle where parents come out and they enter, as well as buses to drop off and pick up kids. And the road here is Guadalupe Road. It's east of Power for those that may know the area. And it's technically a 5-lane arterial. Adjacent to the school, they widen it to 6 lanes, but they're also using the extra pavement for a dedicated right turn lane, as you can see here. At the time, around 1998, the traffic volumes were around 4,000 vehicles per day, so not too bad. Fast forward to 2019. You see here that now the whole road was widened. It's now 7 lanes total with 3 lanes per direction. And on the southeast side, there was a residential development that came in that's also added to the students walking to the school. The dual speed limit is still in place, but now we're dealing with 12,000 vehicles per day. So that's 4 times as much as we had way back when it first started. Existing field conditions. You see a couple of photos of the ADA facilities or the lack thereof. The school didn't have a proper ADA path to the school entrance, and also it ended up in a 6-inch curb where the little crosswalk is that goes to the front of the school. You see it in the bottom photo. So really no ADA connection. We have existing ADA users that required accommodations. And at the school driveway coming out of the school, we had to have a left turn prohibition because people coming out of that driveway would directly interfere with the 15-mile-an-hour school crosswalk. It was directed to the left of the turning movement. So in order to avoid that, we had to install the left turn prohibition. And what ultimately happened is most people then would just make a U-turn coming out of the driveway somewhere to the east in the middle of the road and then turn back west, because about double of the students would come from the west of the school. But again, the left turn prohibition had to be installed because otherwise we had conflicts, even more conflicts with the school crosswalk. In about 2018, the city of Mesa had a goal to convert or at least enhance all 15-mile-an-hour school crosswalks that were on arterial or major collectors. This specific location that was elevated because of the development that came in on the southeast corner when the road was widened to 7 lanes. We also looked at other options, and one of them was the rectangular rapid flash beacon, or RRFB. For this particular application, we figured that the speed limit was too high, especially outside of school with 45 miles an hour. The road ultimately too wide, too many lanes to cross. And we didn't have an opportunity to install a pedestrian refuge, raised medians, where the school crosswalk was. We also couldn't locate it farther to the west because it would have interfered with another driveway. And we didn't want to install it even farther west, where it would then be inconvenient for any kids walking from the east because they would have to go out of their way to get to the school entrance. And we figured if we move it from a convenient location, kids wouldn't be using the crossing anymore. So the current location where it was really the most convenient location. We also looked at a pedestrian hybrid beacon, but we were concerned that it wouldn't control the driveway, it would just control the main arterial. And we tried to also increase the exiting capacity from the school by eliminating the left turn prohibition, but we would have been reluctant to do that with just a pedestrian hybrid beacon. So we had concerns with the efficiency ultimately, and also with drivers exiting the driveway complying if the pedestrian hybrid beacon was activated. So ultimately we landed on a decision to install a traffic signal. And now I'm going to turn it over to Chris to talk a little bit about the design parameters that they were dealing with.
Thanks, Sabina. So these pictures are from the scoping field review that we had with the city and our consulting team. We had on our team Premier Engineering to do the survey, and they did a great job. And Point Engineers was also on our team to do the sidewalk ramp design, and they also did a great job. So we kind of had the normal host of utilities. We have Mesa ITS and Zio running east-west on the south side of the road. We also had on the north side of the road in the middle picture, SRP overhead power. And we also had, as you can see in the blue stake there on the sidewalk, we had underground facilities as well, including gas. And everybody in the office makes fun of me, but anytime I see the overhead power, I throw my hands up in the air and I say, it's going to be a disaster. But in this case, I just went in and measured the CAD this morning, and we were 14 feet away. So as long as you're at least 10 feet away, you don't even really have to send anything in to SRP to get a special clearance. One other thing I wanted to point out is where it says CenturyLink there was multiple utilities on the southeast corner of the intersection, and landscaping, landscape irrigation, just a host of things we wanted to stay away from on the southeast corner of the intersection. So you want to flip, Sabine, to the next slide. The design vehicle, we show here a path. Our team ran an auto turn template for the AASHTO standard school bus. And in particular, the eastbound to southbound right turn movement, you can see in the picture here, it fits, it's tight, but it does fit. We used a standard 30-foot radius, and that appeared to be able to accommodate the bus. And for the signing and striping, we had a 16-foot wide southbound lane. You can see the bus fitting into that area. And we have two 11-foot northbound lanes, one for left turns and one for right turns. So if we had to, we could have pinched the northbound lanes down to 10 feet, but 11-foot was probably better, especially considering that the buses also exit northbound from the same driveway as well as come in southbound. And you'll see a little more on that later on in the presentation. There were some design constraints too. Primarily this catch basin here on the southeast corner. You can see how that lines up with the drainage patterns there, and it goes into the basin here for the HOA and the new development on the southeast corner of the intersection. can see that we really did not want to get into this because it would have been a major effort on what was really just a traffic signal installation project and ramps and sidewalks. So this really held our design, was we did not want to get into these catch basins on the corner. One other constraint was just the overall width of the driveway. We did not want to get into the walls, and we did not want to widen the school driveway. Those were kind of hard and fast constraints, that we did not want to get into the walls of the school. And because the driveway appeared to be wide enough, we thought we could design around that. So next thing I want to talk about is the pedestrian path grade. And if you look at the picture on the left, you can see the existing condition before we started was pavers. Looks like there's some landscape water, and you can tell that the students just walk wherever they want to walk to get out to the existing school crossing. And then in the middle picture, I wanted to show that the grade to get down from the existing Guadalupe Road sidewalk down to the school parking lot was pretty significant. So it presented some design challenges to the team. And since our sidewalk was not parallel to the roadway, we fell under the category or the criteria of having to be less than 5% to avoid being classified as a ramp. So as you can see there in the design plans, it was 4.6%. The team wanted to give a little bit of extra leeway there for not perfect construction conditions. We also purposely ran a running slope and cross slope below the ADA requirements. So, just in case things weren't, as I said, weren't perfect. We also had to thread the needle between two existing retaining walls. And you can see in the picture on the left there, we didn't want to redo retaining walls and things like that didn't add a lot of value to the project. We really wanted to spend the money on doing ADA sidewalks and a path that the students would use. So that was the other thing, is the natural footpath of the pedestrian traffic. Junior high students are not going to go on a zigzag route or do some big curve out of their way. The shortest path is going to have to be the path that we take. And we were honestly pretty lucky to be able to fit it in between the two walls, still meet ADA criteria, and then have our flat landings on either side of the end of the sidewalk. And so it was a very interesting and challenging project to fit this sidewalk into the design.
All right, thank you, Chris. I'm going to talk a little bit about the traffic signal timing, because we don't typically do that, but we had the opportunity here to implement an exclusive ped face. So we have two crosswalks, one on the west leg, one on the south leg across the driveway. And we did not want diagonal crossings, but we were implementing the exclusive ped face to have all the pedestrians cross simultaneously, just to avoid any kind of conflicts with vehicles. And we run this pedestrian time by time of day, only in the morning and the afternoon during school start and release, to really eliminate any kind of touching points between vehicles and pedestrians. There's a lot going on at this driveway. Again, there's buses entering, exiting. There's another school farther to the south that uses the same driveway. And then there's a wall on the right-hand side of the driveway exiting that limits visibility. So we were concerned about vehicles even turning right on red. But we've been observing it and that worked well. But everybody's stopping, all the vehicles stopping as pedestrians are crossing. We also added some more walk time. The crossing along the 7-lane arterial is the timing we base it off of, and we added a few more seconds to that. So both crossings are timed with the same time, so more than actually needed, but we wanted to make sure we also account for large pedestrian groups, students when they're leaving the school. And ultimately the intersection runs free. We do have advanced detection on the arterial in case we need more time for through traffic if it's needed. This location, we did not coordinate it with any adjacent signals. One to the east, the traffic signal is 3/4 of a mile away, so it wasn't necessary. And the signal to the west, which is Power Road, is only 1/4 mile away, but it's on the adaptive system. So ultimately it runs free. I'm going to touch on the ultimate project scope. Briefly, you see here the layout. The one thing that's different here is the crosswalk on the driveway. That's actually high visibility. So we did stripe that with the ladder style or high visibility crosswalk. But other than that, this is how it was implemented. We have the 16-foot entering lane to the driveway, made that wider to accommodate buses, 11-foot travel lanes coming out, as Chris mentioned, 30-foot radius. So we had to reconstruct the driveway, but we didn't widen it. We added more concrete on the southwest corner to allow for a larger student queuing area. And we restriped the road to accommodate this new crossing. And the 15-mile-an-hour school crosswalk was removed as part of that. So this is just functioning as a standard intersection now, which is standard when you get a traffic signal. The school, we had communicated with the school along this whole time, and they had agreed to do some concrete work to connect to the roadway with the design that Chris has just alluded to. So they said we were going to do some concrete work. It was their contribution to the project because the city paid for everything else. So we were coordinating with them. They got the plans, and everything seemed to be good. We started in July, and the first challenge we came across was the ramp on the southeast corner. This is rotated a little bit, but that's the plan view of the southeast corner. And this is what the plans showed in comparison. Then this is what was constructed in the field. Kind of looks right, maybe not enough concrete, but ultimately this is how it was intended to be built here on the third picture. And if you compare that picture with the plan view, you can probably see that that was fairly tough to understand. And the odd thing here in this corner is we needed that second ramp because there was an existing walkway that students used along the wall to get to the school. And it wasn't a sidewalk, it's basically just part of the pavement. So it was somewhat of an odd setup, but we didn't want to take it away because they've been doing that all along. And we were worried if we took that away, they would still do it, but we wouldn't have an ADA connection. Now, how could we have prevented this error that happened in the field? For one, the plans could have had some more information, show the truncated domes that were omitted, show some slopes, some more grades to make it more clear. Since that was a unique corner and we knew it going in, we could have done a better job talking with the contractor. It was Talus, by the way. They did a great job, for sure. It was just tough to decipher. And again, we did have a pretty aggressive construction schedule. So not a whole lot of time, but we should have done a better job communicating with them of what the expectation was. And they could have also come back to us with an RFI, but everything was moving fast. So next time we will make sure to specifically talk about specific items like this that are not standard. This certainly wasn't. So on the right, I'm showing a picture where you can see a little bit more information on the actual plan set that may have helped the situation. The next challenge had to do with the school agreeing to build the ADA connection to the school. I had briefly mentioned that earlier. They did build the connection, but the grades did not match up to what we were building. So ultimately, we had to remove the concrete that they had installed, or most of it, and re-pour. So we had to do the work again. And we should have really sat down with the school. And even though we were in communication with them, we never had a specific meeting about constructing the sidewalk. So they just did it at some point without telling us. And clearly, it wasn't enough information on the plans, or maybe whoever read the plans didn't exactly understand what was to do, since it was a fairly delicate area with having to fit between the two retaining walls that you can see on the picture, and definitely could have improved on the communication there. Some other factors I wanted to mention that could have contributed to some of the issues were the delivery method. We chose JOC, job order contracting, mostly because of the time constraint, and there wasn't really a whole lot of construction that had to be done that wasn't standard. It was really concrete work, the traffic signals, and nothing out of the ordinary, which is why job order contracting really worked well, but it also lacked on the design side a little bit for that specific delivery method. Again, we had an aggressive time schedule. We did the work over the summer break in the month of July. And because of the issues we ran into during construction, the work was completed the Friday before the school started. So we had zero time for testing or even, having a bus drive it or doing anything before that Monday. But we were hopeful. Everything looked good. Everything got done. That was our big goal. We did worry a little bit that it wouldn't get done, but everything was set in place and we were ready to go out in the field Monday morning to observe, which is what we did. We did observe, and I had staff out in the field. I was watching from our transportation management center from the camera, and what we saw wasn't what we expected, to be honest. I'm going to play a little video. Chris took the video. He came out in the field. We told him what was going on. I will speak to that a little bit more after watching the video. So he came right out to figure out what's going on. I was watching from the other side. You see a camera on the other side of the intersection. So I saw the kid standing on the corner while Chris was filming. And then I hope you can see this, but this is what we saw. And I have to admit, from watching from the other side, that was a pretty scary sight. I didn't think the kid would still be standing there after the bus turned, but luckily he did. But my staff came back after the school started in the morning, and they told me what was happening. So the buses couldn't make their turns. It was very dangerous, and they were trying to get kids to move back so the buses could make their turn. Parents exiting the driveway would also pull up quite far. So we're trying to figure out what the issue was. I had asked Chris to send me the CAD file so I could run the auto turn and see what's going on, and that seemed fine. We're all brainstorming, trying to figure out what's going on. So one thing that we quickly came up with was potentially that the stop bar may be too close to the crosswalk. So cars were encroaching and buses couldn't make their turn. So I over the lunch break, I had our striping crew go out and hatch out a little bit of the stop bar area to push back vehicles that are coming out farther in hopes that they would stop back and give the buses some space until we could figure out exactly what was going on. So that was our first approach, and that was briefly done. And then one of my staff got the Gilbert School District to come out with a bus. They drove it again before school let out. It worked kind of okay. With the space available, they could make their turn. But it wasn't ideal yet. It's just the quickest we could come up with on such short notice. So the afternoon came around, people out in the field again, my staff was out, we were ready to do whatever we needed to do, and ultimately pretty much none of the parents or none of the vehicles that came out of the driveway were stopping farther back. So we had the same scenarios in the morning. Buses couldn't make their turns, vehicle had to move out of the way, kids had to move out of the way, and it was pretty chaotic. And by then, school principal was calling me, the school resource officer was calling me, so everybody was up in arms about how this is working and how scary it is, and we need to do something. And ultimately, one of my staff, while we're standing and looking at this exact view, we finally figured out that the radius on the right side where the buses turn wasn't constructed correctly. I don't know why we didn't figure it out earlier, to be honest, but nobody really keyed in on it. I mean, I got the CAD file and I looked at it in CAD, but I didn't compare it to what was out in the field. Didn't even occur to me, but yeah. So that radius was built at 15 feet and not at 30 feet. And when we walked out and laid out the 30-foot radius, you can see here with the red line, it's essentially exactly where the buses would cut the curb. That's the 30-foot radius. What we did then at the end of the day, we hard closed the left turn lane, essentially went back to operations before the traffic signal, so people could only make a right turn out of the driveway for the time being. So didn't really lose anything there. It was more congested, but at least it was working for the time being until we could figure out how fast we could get tallies out there to get it fixed. And I have to say, they did it really quickly. It was the weekend, 2 weeks later. So we had the left turn lane closed for 2 weeks, and then over the weekend, they removed the corner. They reconstructed 2 ramps. They had to relocate the A-pole that you see in the picture on the right, and everything was up and running again exactly 2 weeks after the first day of school. And this is the view of the finished product. Aside from the corner radius, we also adjusted the stop bar on the south leg here a little bit. We moved it back 10 feet instead of our standard 5 feet in hopes that drivers would comply and stop back a little farther so that turning vehicles, especially buses, would have more space. And I have to say, it really worked out well. I'm going to play a video where you can see the exclusive pit phase, and then I also have a couple buses making that turn. I'm hoping that works. And that's during school release last week. We still don't have all students back, so it is not as busy as it normally is, but it gives you a good representation of how this operates. Now we have the pedestrian phase. All the kids are going. And the vehicle on the south side is stopping far back, which is great. That's what we wanted to do. Now you can see the 2 buses coming up. We've also noticed that it depends on the skills of the bus driver. Some are a little better than others, and you can see the difference here between the 2 buses. So the first one is making their turn. He's taking it a little bit tight. So he still runs a little bit over the curb there at the end. Second bus swings wider and has no problem. So really, for the most part, if there's an issue, it's mainly because of how they're taking the turn, not because there's not sufficient space. The construction costs to Thales, the contractor, were, you see, $273,000, and the total cost of the project with design and everything was $422,736. Everybody's happy now. It's been working great. They initially used to have a crossing guard still at the crossing last year, but this year it's not necessary. We were out there a few times during school. Everything works fine, no issues reported, and I think ultimately now everybody's happy. With that, I'm going to conclude my presentation, open up for questions and discussion.
Thank you, Sabina. I have a couple questions here. I just wanted to point out too that when I was taking that video, I did not feel that the student was actually in danger. He was on his cell phone and he knew the bus was there. But if I really thought he was in danger, I feel like I would have stopped filming and would have pushed him to safety, but that's probably not the case. Anyways, it does look, you could see the gravity of the situation. So the first question, Sabina, is, was the right turn lane widened, or I'm sorry, was the right lane widened because of the turning movements, or were the concerns about the lane adjacent to, or were there concerns about the lane adjacent to the curb and gutter? And if you want, I noted that on slide 11 was probably our best picture of that.
Okay.
But I could speak to that a little bit in that the lanes on Guadalupe Road were 11 foot each, and then the bike lane was 5.5 or 6 feet. So based on the extra space available from the bike lane, we do have almost a 17-foot wide right turning area, but that includes the bike lane as well. So we did not make a special adjustment to the width of the right turn lane. If you want to add anything, please go ahead.
Yeah, you covered that very well. We did not. We typically don't, and again, with the bike lane here, it wasn't necessary.
Okay, a second question is, how does the signal timing work for after-school activities such as dances and football games? If the school has a public swimming pool, does the signal still work the same during summertime and public swim schedules?
They do not have a public swimming pool or anything. We run it for 2 hours in the morning because there's 2 schools, and then for 2 hours in the afternoon. But other than that, outside of special events, it runs with normal PED phasing, meaning north-south and then east-west. They go with traffic, and it hasn't been an issue. It's really the big masses in the morning because there's 2 schools starting and 2 schools letting out with the buses. But outside of that, for events, we haven't had an issue running it with standard signal timing.
Okay, we have another question. Did the movement of the stop bar impact the site visibility for exiting traffic?
It didn't make it worse. Now looking to the right, even where the stop bar previously was, you'd still have to encroach into the crosswalk to be able to see to the right. So moving it back didn't make it worse, but obviously didn't make it better because you just can't look to the right with the wall. We were out there observing quite a bit, and we did ask the school to reach out to parents to make sure, but we realized that a lot of people know the area, and whoever's exiting there, it's not their first time, so they see the wall. They understand that they can't look around the wall, so they do stop and then slowly encroach if they don't see anyone. So it's been working well.
Okay, we have a few more questions. How did the City of Mesa handle public outreach on this project? And I know there was some history to this signal location, but do you want to talk about that a little bit, Sabina?
Sure. For this particular location, we really only worked with the school. We didn't do any public outreach. Other than there was some notification of the neighborhood when the construction started to make them aware that this is happening and that there may be some restrictions on the road. But other than that, we didn't ask for input on the location. We did have another location in mind before, farther to the east, because all the kids that are walking, they come from the east. There's no kid coming from the west. It's too far. The first homes are farther away. And also they would come in earlier. They wouldn't even go to the intersection. They would walk onto the premises before this location, but ultimately there was really barely anybody coming from the west, especially not from the north side where they would have to cross. They would be able to cross at the intersection prior. So we were going to move the signal to the west to a public intersection, but the signal there was only warranted because of the pedestrian warrants, not because of delay. So we got pushed back to not install the signal at a public street when it wasn't needed. And we ultimately put it here at the driveway. But there was no specific outreach whether or not the neighborhood is in support of this. It was, again, just that we're constructing it and that there should be aware that there's going to be restrictions.
Okay. Another question here. How did you decide to use high visibility crosswalk markings at this traffic signal?
We used it there because of the high pedestrian volume, especially on the southern crosswalk. Again, this picture doesn't show it, but we did add it. We wanted to really create attention. I know in the past here, we had a lot of drivers, and it's probably because it was 6 lanes, a lot of drivers disregard, even with the school crossing guard, the crosswalk. So we maintained the high visibility that was there before just to make it stand out more, and we added it on the south leg to especially to create more attention from the drivers. So it was based on the fact that it's by a school and that we had high pedestrian volumes in the morning and afternoon.
Okay. I have one question. I know you received some positive accolades from the school resource officer and potentially even the principal. I do think it was a good combination of engineering, contractor, and the police and city staff all working together to solve this problem. But talk about just how it's not normal to be able to reconstruct a corner within a week or two. And do you ever get positive accolades on any of your projects?
We do, yeah. This one, the first day, like I said, the first day was really crazy, and the principal was very concerned, and so was the school resource officer. But once they realized we're working on this and we're doing things, we're not leaving them hanging, they were satisfied. Now, they were still concerned, but when we closed that left turn lane, there was enough space for buses to make the turn. And so they knew, we kept them abreast of the schedule. We let them know we're trying to get this done as quickly as we could. We're working with Talis, and I constantly communicated with them throughout the week and gave them the schedule. And that really satisfied them. They did appreciate that. And once they knew that we're not just leaving them hanging and not responding, they were fine. Even the day of, like I said, I tried to do it with striping. That's the best I could come up with on short notice between morning and afternoon. Didn't work. So they knew we were working on it. They knew we were actively trying to figure out what was going on. And it just took a little bit for us to realize what the real problem was. And once we explained it to them, they realized, okay, it was a construction mistake. It wasn't a problem with the project itself. And when that was fixed and everything operated as we had promised them initially it would, everything was fine. Yeah. We do get positive feedback on projects, but as with every project, there's also negative feedback. It's usually both, but the communication is really the big thing. I've alluded to it earlier too. We can always do a better job. I felt like we were in constant communication with the school, with the sidewalk as well, and they had our information, but it was a school break, so it was kind of hard to communicate. And they realized the project's coming up, so I feel like they probably just went out and installed the concrete based on what they had and thinking they're doing the right thing, and they just didn't have any additional guidance, and also didn't reach out to us. So I've learned that next time, even though we're thinking we're communicating, we definitely need to do a better job.
Sure. Well, thank you very much for preparing this presentation. It was a very interesting project, and it came up with some obviously different and pretty wild challenges to address during construction. And thank you all for attending our session. And thank you, Sabina, for putting this together.
Thank you, Chris, for all your help. Thanks, everyone.